Hi, I'm Mike, and today we're going to talk about measuring for the proper wheels and tires for your vehicle. One of the most difficult parts of putting custom wheels and tires on your vehicle is that, for the most part, a lot of us are not going to want to go with factory sizes. We're probably going to go with plus sizing. The hardest part is trying to figure out what size wheel and tire package is actually going to fit, because a lot of us are going to want to take it to the maximum allowable limits of the wheel well for that vehicle. Today we're going to go ahead and talk about how to do this with some general tools we're probably going to have laying around in our garage. But there is another option, and that is we can go with what's known as a Percy's wheelwright, which is a tool that basically simulates a wheel and tire package. Before we get started on showing you how to measure for the proper wheel and tire package for your vehicle, I do want to emphasize one thing, and that is that you have to simulate a load on the suspension components of the vehicle to get accurate measurements, because what happens is all the articulation and everything else will change the dimensions of what you're measuring. So what we'll usually do, and we're just using this for display purposes today, what we'll usually do is we'll go ahead and take a jack stand and put it either underneath the A-arm or the rear end assembly or whatever area of the vehicle we're measuring, to simulate the wheel and tire package being on that vehicle instead of letting the suspension free hang on the jack. Right now we're going to show you how to measure for the wheel and tire package for the front end of the vehicle. Measuring for the wheels for the front of the vehicle is actually much more difficult than measuring for the rear. Reason for this is because we got to figure out how big of a wheel and tire package is actually going to fit with the wheels in lock-to-lock position in comparison to the rear, which all it does is articulate up and down, and that's it. There is no movement from side to side for the most part. Once we have the suspension system loaded on the vehicle, what I'll usually do is I will go ahead and take the wheel assembly and move it to the lock position, either further all the way back or all the way forward. Now this is not going to be a real good example of this because I don't have a center link or tie rod ends or anything here, so I don't have a natural stopping point on this suspension system. Once I get into that lock position though, what I'll do is I'll go ahead and take a straight edge, probably like a yardstick or just a thin piece of wood or whatever it may be. I'll drill a couple holes in it that match the bolt pattern on the hub assembly. You want to make sure that it's long enough so that you can get all the contact points that can come in the closest contact inside the wheel well, but at the same time you want it to be short enough so that you can rotate it. So you're going to have to figure out what length yardstick is actually going to work for you, or a piece of wood, or whatever you plan on using. Once I get that mounted to the hub assembly, I will go ahead and rotate it, and I'll take measurements then from the closest contact point inside as well as outside, and I'll do it to the full rear lock position as well as I'll do it to the complete full lock position forward, and then I'll also put it in the straight position. This will give you an indication of what you really can get away with. Now, generally speaking, you probably want to use the +2 method at this point, meaning that you want to go ahead and be within 2 inches, meaning that you want to go ahead and figure out what the largest package is going to fit and then take 2 inches out, front to back. This will assure that you don't have any binding or anything like that against a frame, against a tie rod, or anything of that nature. The other thing about that is that we got to go ahead and account for the bushings that are in the suspension as well. Because what you come to realize is, depending on the type of bushings, whether they are urethane or rubber or solid, you're going to go ahead and get different suspension movement as well. And if you take it to the limit, and everything will seem just fine if you go with the max that will fit, but the minute you go down the road and you get any type of movement in those bushings or anything else in that suspension system, now you're going to have a rubbing problem. One other factor you're probably going to want to consider as well is the back spacing of the wheel and tire package that you will be using past this point. So let's say you take all your measurements, you figure out what package is going to fit on your vehicle. You go buy that package, you put it on, and it actually won't even mount up, or you got something binding on the back side. What can actually happen with some of these wheel and tire packages, especially on some of these older vehicles, is because of the A-arm assembly that they're using, that the inner hoop of the wheel actually interferes with the A-arm assembly. And what you'll notice is, from the factory, what they used a very shallow backspace wheel so that it didn't actually interfere with the A-arm. So let's say you went with another 14-inch wheel or another 15-inch wheel, right, which has a fairly small inner hoop assembly on the rim shell. Well, what happens is you go with like a 15 by 8 or 10 on the front now instead of a 15 by 6 or a 15 by 7. And you needed a lot more back spacing to actually get it to fit inside that wheel well. what you'll actually discover is that because that wheel diameter on the inside is so small, that actually binds up against the A-arm. Typically this isn't a problem with wheels like 17 or 18 inch in diameter because there's a large enough inner diameter assembly to accommodate that. But on the smaller wheel sizes, you may need to take this into account. So as you can imagine, everything I talked about today really isn't a perfect science, meaning that there's always going to be some sort of variables that you may encounter. Even when you take all your measurements, you think everything is 100% correct. There are solutions to some of these problems sometimes. One of the solutions could be a real thin spacer. We sell 1/4 inch spacers and 1/2 inch spacers to go ahead and account for some of the measurement issues that we encounter regularly with wheel and tire packages. Or you could have a situation to where you measure out one package and we don't even have a wheel that has the proper back spacing, and you want to get away from ordering a custom backspace wheel, which can get really expensive. So now you have a situation to where maybe a spacer is a viable option. Just remember, when you go ahead and use spacers, you may have to go ahead and change lug nut design with a lug nut that has a slight shank on it, or you may actually have to go with a longer wheel stud assembly. Go from maybe a 2-inch stud to a 3-inch stud so that you have proper thread engagement. All these are viable options. The one thing I just want you to remember is that we don't have all the answers when it comes to this stuff sometimes, and we're going to need your help to figure these things out. Stay tuned and keep an eye out for other videos about wheels and tires. Thanks for watching.